Thank you. Thank you, Rohit. And again, welcome to this next session of the webinar series being organized by Skill Council as a part of the Azadi Ka Amrit Mahotsav, which is an initiative by the Government of India to celebrate or commemorate 75 years of our independence, and also to celebrate the glorious history of our people, culture, and our achievements. This Mahotsav is dedicated to the people of India who have been instrumental in bringing India to this level, and also taking part or contributing to India becoming a big global economic power. A lot of activities have been organized to celebrate this activity, because this is a global movement, and there are seminars, workshops, and of course exhibitions, talks. So many activities have been organized to celebrate this Mahotsav. And we in Skill Council decided that we would be holding webinars in all the topics in which we are working, like renewable energy, waste, water management, sustainability, zero emission, so that we can invite learned people, learned speakers, and we can learn from them. We can learn various developments in these fields, in these sectors, and we can also interact and get more and more ideas how we can take this activity forward in a Skill Council. Now, biomass is one of the most important sector, and like we've been discussing, it has, when you talk of modern bioenergy. You don't say biomass. Biomass was earlier associated with traditional activities. Agriculture has always been all biomass. Most of the farmers, or more than 70% of our population, which is in the rural areas, was dependent and was associated with biomass. But now with the net zero, goals coming up, and with the other goals or priorities which have been taken up by India in all the international forums, modern bioenergy technologies, modern bioenergy, devices or systems which produce clean fuel, and also we can do away with the problems of pollution. We can do more. There can be more income generation, and there can be more livelihood creation when you use the modern bioenergy systems. So that has become a very important area, and you will see more and more very specific interactions in the form of conferences. Like recently I had attended the densification conference. Now, densification of biomass is a very specific activity, and now having a focus only on densification becomes something that this area is, not only the technology is important, but also the biomass supply chain, how we arrange it, how we ensure that a sustained supply is given to the technology projects. So this has also become very this thing. And in Skill Council, we have been focusing right from the first day since the government launched all the initiatives. We had Saket, we had Govardhan, and we had so many, the National Biofuel Policy. In fact, I had the privilege of being with CII for the task force on bioenergy, and the supply chain was, I had pointed out that this is where we should focus. So we could focus on the supply chain, how the supply chain should be maintained. You should open up biomass banks so that there is information data with the farmers, so that they can have a storage system, they can have a supply system. So this has all gained a lot of importance, and in Skill Council, we have been studying this sector, rural waste, farm waste, urban waste, and we have developed training modules where we could connect with the workers. Waste management, urban waste was easy, but farm waste was difficult. So here we had the opportunity of doing the first training with HPCL and connecting with 1,000 farmers. And I'm very happy to share that today our learner speaker also was the leader in this. Mr. Dhingra was the leader in guiding Skill Council for completing these trainings. So I think with this background, Mr. Dhingra, you are welcome. And we are very fortunate that we have you here, and we would like to know more, and we would like to work more with you in our further projects. Now, I would request Mr. PB Singh to kindly introduce. Thank you, and welcome once again.
Thank you, ma'am, for welcoming the speakers and other participants. Mr. Sunil Dhingra has a mechanical engineer, and Mr. Sunil Dhingra has a MTech in mechanical engineer. He's he has worked for over 32 years in renewable energy, including biomass and waste to energy, solar and hybrid energy solutions, distributed generations, decentralized energy and environment sectors, and allied areas. He specializes in the field of renewable energy and development, especially focused on the clean biomass and waste to energy based thermal energy solutions uh, for fuel power, cooling, drying, and heat solutions and policy areas, including agriculture, industry, transport, commercial, and rural sectors. He has a he has a director of Biotrend Energy and promoting biomass applications, etc. He is the member of the several uh, project monitoring committees in MNRE, Hareta, and DST. Also, he is the committee of review decentralized distribution generation under Rajiv Gandhi German Vidyutikaran Yojana. He is honored and awards are the Energy Globe Awards 2001 in the category of sustainable energy and received for our projects titled Introduction of the Gasifier Technology in Skilled Industry. Second is the Energy Globe Award 2002 for the project Improving Profitability and Sustainability of Indian crumb rubber industry by introducing gasification technology. Now, I'm requesting Mr. Dhingra to start the presentation.
Just to add that
Over
these are
to you,
very
sir.
few achievements of what we have said about Mr. Dhingra. He has many more into his credit. And I think recently you had something with AFC also, Agriculture Finance Corporation. So he has much more national and international achievements to his credit. So once again, I also welcome you. And please, the floor is yours.
Thank you. Thank you so much for introducing me and inviting me for this very important webinar series, which has been organized for last year and so. So the topic, which is very, very prominent for India, which is on bioenergy, which has multiple dimensions for solving multiple problems which is the country is encountering or trying to address. So let me first share my screen with you and give you my perspective, views, reflection on bioenergy. Then I will come to the slide which I have prepared for the audience today. Just a minute. So could you see my introductory slide now?
Yes, sir. It is visible, sir.
Okay, thank you. Thank you so much again. And thank you once again to Skill Council for Green Job, Dr. Praveen Saxena, Dr. Praveen Dhamija, and PB Singh for introducing me and inviting me for this lecture series. Let me start with very important quote by UN Secretary General very recently, and very alarming statement. So he said that, and I quote, on era of global warming is over, and era of global boiling is has arrived, which is a very, very alarming state as far as environment is concerned, climate change is concerned. And this is the year when we have all global level, this planet has experienced the highest temperature or the heat at all across globe. And so this is very, very alarming statement for us to arrest the global warming or global boiling. Otherwise, the boiling operation physical term will evaporate, and we normally use in boiling. So mankind existence will be in very much in difficult situation. The second important element I would reflect is biomass or bioenergy is the oldest form of fuel the mankind or this planet knows. And this is also be the importance of bioenergy is been referred in Vedas, in India Vedas. The importance of bioenergy is very, very critical element in our historical Vedas. The third point, which is in 2018, when National Biofuel Policy was launched by Honorable Prime Minister, and the whole idea was to make our farmer, which is Annadata to Urja Data. So it is not about agriculture, food production, but also the same agriculture will bring Urja, that which the energy, the sustainable energy, which is the mantra of Annadata to Urja Data, to increase farmer income, increase energy security, reduce dependence on fossil fuel, which India import, and also many other co-benefit which is there on the bioenergy side. The third very important element is, among all renewable or clean energy form, bioenergy is the most versatile form of energy. Why so? Because it can be used in all three physical forms, which is solid, liquid, and gaseous form. And that is what the society today experiencing. Solid in form of a biomass pellets, biomass briquettes, and at global scale, this is a very big industry now. Then we are talking about liquid forms like ethanol, methanol, and other forms of biodiesels, for example, which is the liquid forms of bioenergy. And gaseous form is CBG, biogas, and syngas, which can be further transform our energy sector. So it's a most versatile form of renewable energy. It can meet all our basic and needs of energy in all forms. India has very relevance for bioenergy development historically, because if you look at the statistics, almost about 600 million people directly or indirectly depend upon agriculture or allied activity, their livelihoods. So it's a very core to sustaining 1.4 billion people food system, and also going forward energy system. Also using this, the word Dr. Dhamija talk about is modern bioenergy system, because the technology is available. So with these contexts, the importance of bioenergy, the climate change challenge, this is very critical. So I will now introduce my slide, which I have prepared for this webinar. So let me see, if you look at the India renewable energy actions since 2015, India being the only G20 country to be on the path towards well below 2 degrees Celsius, which is the Paris Agreement goal, which has been set by all the countries. And India is well meeting that the target of Paris Agreement well before time, and installed 175 gigawatt of renewable power before the target of 2022. And going forward, we have the country has committed to achieve 450 gigawatt by 2030. And to meet this target of 450, the transformative needs towards renewable electricity, which is the core dimension to our NDCs, hydrogen and bioenergy as a key fuels for different sectors are critical element of net zero carbon emission target, which has been set by our Honorable Prime Minister by 2070. And if you look at from the potential of bioenergy in form of agriculture residue, livestock waste, or urban solid waste, which are not being very effectively used currently, can supply more than 19,000 petajoule of primary energy. and which is almost 50% of our total primary energy requirement. So it's a huge segment as far as energy security is concerned for us. And almost 50% of our total primary energy can met through this potential, which is also growing from many dimensions as we talk about. If one look at from this slide, which we talk about the energy generation and the RE contribution, we have roughly about 421 gigawatt of installed capacity of electricity in the country. And if we look at renewables without large hydro in the overall mix of this pie, we have already 30.7, and we consider large hydro as many countries in the developed world consider that as a renewable. Then we have close to 41% mix, which is quite a good mix of renewable energy currently. And these are some of the achievement, as you can see from different renewables on the table below: wind power, solar, biomass, biomass in bagasse form, biomass in non-bagasse cogeneration application, waste to power, and waste to energy category. The achievement which has been achieved in renewable energy sector. Now, biomass is very critical dimension to import dependency the country is facing. And as you can see, these two slides, one on the left and the other one, which is the crude dependency in the country, we have close to about 86% of our crude in the country is imported. So our dependency is very high, and also which lead to a lot of energy security issue in the country, while a lot of geopolitics challenge which the world is facing, so this need to be arrested by use of local biomass resources or local resource, clean energy resources. And as we see, the use of natural gas is as a clean energy source from the air pollution point of view is increasing. And our import dependency on natural gas, we are importing almost about 50% of our current need. And more gas is being injected into many other sectors in the economy. So we see the dependency on natural gas import is also increasing, as you can see in this particular graph. So these are important elements which need to be seen from development of bioenergy and bioenergy resource in the country, from both policy and also from the technology perspective, to make India self-sustained in bioenergy or domestic source of energy. And also at some stage, like we talk about when the hydrogen mission was launched, to be major exporter of green hydrogen at a global level. So these are some of important element of developing renewable energy or bioenergy is important. Now this slide talk about the potential of, and as you can see, the agriculture waste. So this was 2018 data by TIFEC for 11 major crops, which are mostly grown in major crops which are grown in India. 680 million tons of agriculture residue is generated, and out of which 170 is considered as surplus, which is burnt on the field without being economically harvested, which is and due to which the challenge of air pollution and health during paddy straw stubble burning is happening in northwestern states and also in other states also. Livestock waste, we have the largest population, and if we consider 50% of that waste is channelized through anaerobic digestion system to produce biogas, then potential of something around 225 million ton of biogas generation is possible using 50% of the available livestock waste in the country. Then you have forestry and plantation waste in form of bamboo, pine needles, and lantana, which is growing in forest area. And then you add the fourth pillar of the bioenergy is municipal solid waste. So India generate about 188 ton of MSW daily, and which amounts to about 70 million tons of on annual basis, which can easily be converted with the current technology which is available, and can be utilized for energy application to meet the growing challenge of climate, energy security, import dependency. All that is feasible with these kind of a resource today. And so this is more on a segregated number, what type of crops which we are talking about: rice, wheat, sugar, cotton, maize. And India, the top 5 crops, we are either number 1 or number 2 at a global level in production. And as we speak, currently, this number is close to about surplus quantity, 230 to 250 million tons, which has been estimated in the recent reports, which was published by MNRE, for example. If you look at from the state level, because biomass, which is so if we look at states like Punjab, Maharashtra, Uttar Pradesh, which has high biomass or agriculture activity, high amount of contribution or resource is there in terms of biomass energy perspective. Then, of course, then other states like Haryana, Madhya Pradesh, these are critical state to develop bioenergy to utilize this resource. And now one element, because there are many people, why crop residue is burnt on the field and what are the challenge. So one of the challenge, the crop residue is burned because of the intense, and which is intensifying in recent year due to shortage of human manpower. The labor for the agriculture is limited. High cost of removing crop residue by conventional method, and use of combined, because a lot of mechanization has happened, particularly in states like Punjab and Haryana in recent past, because of which farmer has no other alternate but to burn that on the ground if there is no economical or value addition in the demand side of that. And the issue is also very because residue of rice, wheat, cotton, maize, and millet and sugarcane, these are typically burned on farm across different states of the country. And this problem is more severe where rice wheat system is there, because of the window of collection of rice paddy straw is limited, because farmer has to sow the wheat crop. Only 2 or 3 weeks are available to him. Because of, like, for example, in Punjab, which generate about 20 million ton of parali, the paddy straw, managing that in a short window of time with lack of facility of storage, equipment for baling, then most of that is burned by farmer, despite so much of regulatory challenge and other mechanism is there. So if we look at from the key challenge in India compared to other developed country, one, this is a dispersed resource. It is because our land holding is limited. It is very much dispersed so collection becomes equally very challenging. It is seasonal available. So for any system, energy system or any other industry in a circular economy, if it depends upon such kind of a resource which is seasonal available, then its viability becomes challenging in true sense. So any post treatment required a sustained supply. Like, for example, if some industry using coal, for example, or thermal power station use coal. So if they have to shift to these kind of a fuel, because of the availability is seasonal, of these biofuels. So the supply chain model has to be set up for this challenge to be overcome. Seasonal availability, dispersed resource. And the other important challenge is the crop residue being light, difficult to handle, expensive to transport in a loose or in the raw form, for example. So some pre-treatment in form of densification we talk about. We talk about baling it. We talk about making it briquettes and pallets at the decentralized scale is critical requirement in for meeting scaling up this resource. And majority of our agricultural landholding is small, so a lot of collection become even challenging at that scale. So now the question came, the technology works of bioenergy at both decentralized level and centralized level. Centralized level aggregation become challenging, and the reason there are 4 bullets which is highlighted there. So we believe that the answer for India bioenergy or agriculture based bioenergy is on decentralized scale of technology implementation. It has to be at the decentralized level. And once this processing is done at a decentralized scale, then you can transport to different economical segment like industries or for power plant or any other system, for example. And this thing to happen, lack of supply chain mechanism in aggregation, collection, and storage is the critical gap in realizing this potential that we are talking about. And here, I think the role of organization like Skill Council for Green Job and many other institutions is skilling and entrepreneurs development at the local level. And when I'm talking about local level, it is farmers who are the real owner of this resource, which is today a waste, but tomorrow it's a resource for them also. So bringing a model where we try to bring them as a main stakeholder in all value addition, whatever we are trying to do. Without that, I think socially or economically, we just can't look into scaling up this resource. On a biomass conversion technology pathway, there are 2 broad segments. One is the thermochemical conversion, the other one is the anaerobic digestion, which is for the wet organic waste material. So these are broad technology configuration. Combustion, gasification, pyrolysis are the critical element for thermochemical conversion, and they're well developed both for heat, power, and any other energy conversion. Like in combustion, which is used in thermal power station, for industry, making steam out of that, gasification producing into syngas, and this syngas can be further reform into other forms of energy like methanol, ethanol, and biohydrogen, for example. So a lot of project implementation on that scale is currently happening. Pyrolysis is at different rate of pyrolysis heating system. We can produce gas, oil, and charcoal depending upon what is the end requirement with this technology. On anaerobic digestion, very important element is digestion and fermentation, and very basic technology of from non-edible oil extraction mechanically and then transform into transesterification process to produce biodiesel is very important element of this technology pathway. And most of the technology, what I have reflected here, is in a scaling up mode, and it's proven on ground as far as energy conversion is concerned. So these are some of the elements of end user industry, like very basic heat for domestic, heat for industry, combined heat and power for industry, biomass power and cogeneration. We are talking about activated carbon, hydrogen, all that derivative of biomass can come from these set of technology which is required in the society. to grow in a circular economy. These are some of the important policy where a lot of demand of biofuels or bioenergy has been created. And there are many ministries, as you can see in this slide. The prominent one is MNRE, promote energy from agriculture waste in form of biogas, bio-CNG, and they provide CFA support for such project to come up in the target states. MNRE also promote grid interactive biomass power, both in sugar mills and also in other industry. And there are provision of capital grant which has been provided. As I speak about national biofuel policy, there are two specific programs. One is the STAT program, which is sustainable alternate towards affordable transportation, where 5,000 biogas system at medium to large scale is been planned, and there is a price mechanism by oil marketing company, and this price, whatever is reflected here, is being revised. It is linked to natural gas price and currently varying from 65 to 72 rupees per kg plus the GST, depending upon what is the natural gas price in that particular market. Very important program which is called Samarth program under Ministry of Power, where they have allowed 10% blending of agricultural biomass pellets in pulverized coal-fired boilers. And there is a mission called National Mission on Use of Biomass in Thermal Power Plants, which is important element of creating demand for bioenergy. And a lot of investment and technology has been implemented on densification of decentralized scale biomass pellet production as we speak. Ministry of Agriculture recently have implementing a program called crop residue management to promote bioenergy, where CFA has been provided to set up biomass aggregation and collection depot infrastructure, particularly in states like Punjab, Haryana, Uttar Pradesh, and Madhya Pradesh, and also NCT, where high level of pollution is encountered because of burning of crop residue burning at the farm level. And many state government have dedicated programs to promote biomass power, like and few of them, UP, Punjab, Haryana, Bihar, and many other states have dedicated program to bring investments in their bioenergy programs. So you can see these are not the complete list, but from the policy perspective, government is trying to create a demand of bioenergy across different sectors, which we have talked about. This is the Samarth program as just a figure. India has something around 205 gigawatt of coal-based power plants. And as per our estimate, assuming with 5% blending target, 35 million tons of biomass pellet is required to meet the target of 5%. And it's a huge requirement looking at where we are standing right now. Very, very basic production of biomass pellet or torrefied or non-torrefied fuel. So a lot of investment, a lot of livelihoods, a lot of entrepreneurship will develop around this program. And as to meet this 5% blending target, something around close to about 50,000 new entrepreneur or job creation will happen direct in those biomass-based pellet applications through this program. This is the national program on STAT, which I talked about, and which estimated to produce about 50 million ton of CBG once these 5,000 CBG plants are up running, and which will reduce methane gas or CO2 emission by 229 million ton annually, equivalent to CO2. This is a typical CBG technology configuration, where biomass or any other organic waste is pre-treated before fed into the main digester. And after biodigester, the raw biogas is produced and the impurities in form of H2S and CO2 is removed. Biogas is enhanced to produce compressed biogas and these compressed biogas at a 250 bar is being dispensed for automobile market or any other industrial market which is there in the local community. And whatever the digestate which is coming out in form of a manure can be further made fortified organic manure and sold in the market as a manure. And this has been allowed under the fertilizer control order. So there's an incentive which is also given to this set of industry or this type set of projects. Now coming to what exactly the biotrend we are doing as to meet some of these challenges which I have just described. One critical dimension to this is biomass feedstock assessment, because for any project to come in that particular district or block or a village level, sustained methodology to define sustainable biomass resource which is available on a long-term basis. So we help that industry or investors or project developers to for this assessment study to happen. We do a lot of supply chain management support, ensuring consistent supply to particularly thermal power stations and industry in meeting their targets for bioenergy. We do a lot of technology and process optimization, because many of the coal-based infrastructure or investment which has happened in where there's a life of that equipment is still there. So we help them in implementing efficient conversion of those boilers or those furnaces to biomass-based fuels, and help the market in project implementation and market-related services in case such services are required by project developers. As we are partnered with organizations like Skill Council for Green Job and also Agriculture Finance Corporation with their farmer FPOs, we are providing training and capacity building support in biomass collection and skilling of biomass aggregation and depot creation perspective. We in last couple of years helping rural youth with technology solution and also financing to develop viable business model in biomass aggregation, collection, storage. And these are actual figure on ground where we have engaged rural communities in collecting different forms of agricultural waste, trying to create the economics of the collection and the cost element for the end user industry. So this is what we are trying across states. We are working in different geography. This is a broad scheme of things which are there for paddy straw to pellet production. Because of the paucity of time, I will skip this. We are currently implementing very advanced 100% paddy straw based pellet mill, and 2 such pilot lines are being implemented under a with the international consortium, and these will be up running in the season in October-November cycle. In terms of the technology demonstration or scaling up perspective. And the plan is we are bringing investment to this sector and trying to set up 2,000 such decentralized scale pilots in next 3 years. So this is the plan we have developed, where investment, technology, standardization is currently happening. And this is exclusively 100% paddy straw, which is the most difficult form of crop residue to be handled by any energy system. This is the picture of our Gandhidham factory, where we are making industrial pallet of 6 to 8 mm. And this facility is also being used for training applications. So we are local ITIs, diploma holders, we are training on this equipment, exposing them to different machineries of pallet production, because you require huge amount of technical manpower to support such industries across India. The model which we are proposing is 1000 to 2000 kg per hour pellet mill, and supplying on a long-term basis for 10 to 15 years through this long-term contract with thermal power stations. We are integrating very critical demand of rural areas, which is the cooking energy demand. And here we are bringing very efficient stove, which can work on these biomass pellets, agri-based pellets, and meet the critical requirement in the rural communities for their cooking energy, and also some of the local industries like dhabas, restaurant, where fuel is being used. So this is the model we are trying to, and we call that I-step model. The three critical element of this business model to succeed is one, the sale of biofuel, and that we are ensuring on day one itself as our mandate in the company. We are skilling, which is the critical gap, the technical and management skill in this business. This we are addressing through partnership with Skill Council and the team there, and with many other such institutions. And the third one is collaboration, both at national and international level, for investments and scaling up requirements to promote these social enterprises to meet this decentralized clean energy systems. This is a typical scheme for process of pellet. I will avoid this. This is the institution model, which is a community-led or entrepreneurs-led model in biomass aggregation, storage, and processing. We are bringing the technical competency in terms of technical design, specification, setting of a plant, capacity building, handholding, social engineering, whatever is required to the community to set up this facility. We will channelize that through OEM, and once this, and system owner will be the local communities, and once the pallet is produced, we will 100% buyback under the and try to distribute to household, thermal power stations, and local industry on a long-term contract basis. So this model is more sustainable from in terms of planning, implementation, management. It is a woman-led model because we see there is a critical role of managing local resource by local women in rural areas. So they are, it's a gender inequality we are bringing into this program. We have trained women in this activity as we speak, and of course, each of these pallet production facility through this model will create sustainable job on long-term basis. Sorry. And very recently, as Dr. Dhamija talked about, we have in partnership with Skill Council and HPCL trained about 771 farmers, out of which 124 are women farmers in 5 districts in Bareilly, Badaयूं in last a few months in this summer, and trying to create entrepreneurships in biomass aggregation and biomass depot creation, so that sustained biomass supply is ensured to these pilots which are being done around CBG and pellet production in that community. As you can see, this is a bale which is produced and demonstrated with the local company who is promoting the baler in this region or this districts. This is the clean cooking stove which we are promoting. This is a tier 4 stove, most efficient, and this stove can save about 3 to 4 tons of CO2 annually each stove. So one can save about 3,800 kg of wood, which otherwise used in a traditional stove by using. So this we are integrating in our approach to pellet production and use of energy at the local level. On some of the critical gap which we see in a thermal power station is use of torrefication technology. And we have developed in-house local torrefied unit, which is a continuous torrefied unit, and which has been tested for paddy straw, sugarcane thrash, and corn cob. The torrefied material can directly be used in a boiler or a thermal power station as equivalent to the coal in terms of grindability, in terms of its HGI index, and other characteristic which is required in a thermal power station. Biomass gasification for industrial is a big market for India, and we are trying to promote by use of these biomass pellets and briquettes across different sectors, across different MSME sectors in the country. So by promoting such kind of a enterprises, so the potential impact which we are trying to create through this use of bioenergy is to address air pollution, health issues, increasing the farmer income, because ultimately that waste which is burned, there will be economical value. So the farmer will get something around 1 to 2 rupees for the as a reimbursements to do this resource, and creating an alternate market for bioenergy, which will help India to meet their climate goal and energy security goal in particularly sectors like co-firing in thermal power station, boilers in industry, furnaces, hotel, dhaba, institution, household, you name it. And with more injection of value addition in form of a liquid and biofuels and hydrogen, this can further scale up to that level. So with the last slide, which so there is a vibrant bioenergy market and there's strong demand across sectors with regulatory and price mechanism in place in the country. Political commitment at the highest level to develop clean energy transition, 40% capacity by 2030 in non-fuel, fossil fuel based in NDCs has been committed. Policy tools like programs or programs and policy tools like Samar, Start, CRM scheme, CFA and 2G ethanol price mechanism is driving this investment or these businesses. Opportunity for in all this value addition, there is a lot of opportunity for innovation, cost reduction, performance improvement, and that is what academia and research institution collaboration is currently happening. Like for example, just giving you an example, how can innovation can help in reducing the cost of baling, for example. And the theoretical number is that 1/3 of the current cost of baling can be reduced by more innovation. And that is what collaboration with research and academia is happening at our level. Developing an ecosystem for required skill set to realize this potential is happening. So all this will help us in meeting 2040 target of thermal power stations, industry, transportation, and also sustainable aviation fuel for through SAF by biofuels is an important element of bioenergy development in the country. So this is the whole story in very short, and each of these elements required institutions to work in, businesses to work in, and that is where a lot of new businesses to come in with these new investments. And we are trying to help and catalyze with our experience and with our vigor with this sector. We are trying to do with partnership and collaboration. With this, I will stop and look forward for any clarification, comments, or any other pressing points which I missed in my presentation.
Thank you very much, Mr. Dhingra. Very vivid presentation, very well presented. But still you feel very sorry that so much activity is going on. We are not able to reach where we are supposed to reach, isn't it? I think Dr. Raman is here. Yeah, so if you would like to ask anything or give your remarks, Dr. Raman, can you give him the rights, Mr. Rohit?
Yes, ma'am, I already.
Yeah, and Mr. Sarabjit is also here.
Yes.
Yeah.
Good morning. It's nice to hear from Sunil Dhingra. Almost be knowing that we have worked many years together. And I was going through his presentation. As you rightly said, see, for example, the table which he has presented, the left hand side is 0 and something is there on some numbers are there on the right hand side. The thing is, biomass is not getting that kind of attention. And mostly, I don't say even the technology is a barrier, but some of the cost, because it is scattered and there are many concerns are told actually. We have to look forward as baling and particularly the supply chain management part. We have to focus a lot. Actually, that is the one reason. Because earlier also Philips and the Shell, the Bharat Petroleum, I think there are two companies came here in the similar model, creating pellet and giving for cook stoves. Somehow it was not worked due to the cost associated with the pellets actually. So once when we bring down the cost little bit more, in the particularly biomass processing section, actually, the pelletization, then this will give you a very good boost, actually. But and the another advantage is right now, I think there is a mandatory there in all the power plant to use the biomass briquettes or pellets. That is another thing. So the focus should be there more on the biomass processing part to make it as a success, actually.
That is the most difficult part. What do you say,
Yes.
Mr. Dhingra?
Yes, thank you.
Yeah.
Absolutely. So as you have seen the common challenges which is highlighted, it is well known to the community which is there, and good to know Dr. Raman viewpoint on this. So I think to realize this, the potential, say we are talking about 230 to 50 million ton. So many such institutions has to partner with. Many such investment has to come in. Right now, when we go to villages in Punjab or many other this thing, there's a lack of machinery. So government is creating their part of the investment in coming in. So we will see that there is a push to this activity by private-public partnership. And in next 3 years, some of these potential will be realized sustainably. That is what I could see from the business perspective. And because now I have a very different role. I am not a in institutions like think tank, for example. So purely on the business side of that. And I see there's a huge potential which is coming in, investments coming in to realize this potential. So the case which was different earlier was a lot of demonstration projects were there. And right now it is all businesses led program. So that's the key change I would see, and we will see in next 3 to 4 or 5 years the bioenergy will get mainstream in different sector where it is more promising.
Yeah, we have Mr. Meena also. Mr. Meena, would you like to? Yeah, Rohit, can you give the rights to Mr. Meena?
Yes,
yeah, you have to unmute yourself. Yes.
Yeah. Today presentation is very well, and hope it will be very useful for all the listeners. And for more detail, if about the National Bioenergy Program, we have 3-4 schemes, and we have developed the bioenergy portals, so anybody can access the application, how they can apply, and what is the subsidy, what are the FAQs. and help desk. So if any problem, then you may easily approach to MNRE, and we hope a good number of proposals and many more things.
Hmm.
So
Yeah.
no more.
Thank you very much. Yeah. And
May I ask?
yes,
May I
please.
ask?
Yes, yes. Please
First
introduce
of all,
yourself. Yeah.
my name is Rakesh Chaudhary. I am
Yes.
from NIT Delhi. Basically, I am a researcher here. I am
Yes.
pursuing PhD from here.
Hmm.
So
Okay.
basically, sir, my question is, what are the main challenges you are facing in optimization, in optimizing the efficiency of a biogas plant, and how are these challenges being addressed by you? Sir, should I explain, should I ask again from you?
Optimizing the efficiency of the
this is a-
plant.
Sir,
Biogas.
basically,
maybe
sir, yeah.
we can, because it's a research question which has been posed there. So maybe we can bilaterally discuss this separately. How a biogas system energy efficiencies or improvement, and I would like to know what type of interventions you are trying to do, where you see this challenge for your research or
Yeah.
academic purpose. So maybe my suggestion in this platform is, let's discuss bilaterally this issue.
Yeah. Because efficiency is dependent on a number of parameters.
Sir,
You can't have
sir,
one parameter for determining the efficiency of the plant, no?
sir, basically, which parameters you are considering in the initial stages, whenever you are taking substrate?
Very simple
So it depends on your
thing is
feedstock first. What is the feedstock?
input and
So if-
input output conversion ratio, which is very
Okay.
basic for any energy system. Whatever I am feeding, whatever I am getting out of that is the very broad efficiency for any energy system.
Agree, sir.
To give
Agree,
my
sir.
input at least.
But if you have a biogas based
My-
on cattle dung, it will be different. If you have on a paddy
Sir-
straw, it will be different. You know,
Sir,
because the
my-
processing is different. Yes.
So my feedstock is organic fraction of municipal solid waste
Yeah, Dr.
and
Vanita
sewage
was-
sludge.
Yeah.
And I am considering inoculum cow dung whenever it is in a starvation stage.
Okay.
So basically, I just working on the optimization of biogas through these substrates like organic fraction of MSW and sewage
Yeah.
sludge. This is my core substrate.
I think Dr.
And-
Vanita Prasad wanted to, I think she's also working in biogas. If you would like to, Dr.
May-
Prasad.
Yeah.
are you there?
So for this conversation, I just wanted to say this thing, that optimization of inoculum is very important. If that is done, then there is no need to really think on to the feed type. Feed will be processed by the inoculum, but when you are considering a feast which is having high carbon as compared to cow dung, then the parameters which you are considering for like pH loading or the actual organic loading in the plant is, it has to be changed. That's the only thing we need to monitor. So while planning of a plant, these are very important factors, and while operating you need to maintain pH and VFS.
pH and VFS. Yeah.
VFA, yeah.
Thank you. You would
Ma'am-
like to say something? Okay, please. Yes.
Ma'am, you are telling pH, VFA, alkalinity. I am considering these factors, even though I am taking my substrate in the range of 3 to 5 mm of particle size also. First pre-treatment, I will give in hydrolysis in a thermophilic manner and other in mesophilic manner. So basically, I just want to know your optimization ways. Ma'am, if it is if it is problematic, can I have your contact number, Sunil sir or ma'am, any of the
Yeah,
person?
sir, ma'am, you can share my number with anybody who wants to optimize the plant. We
Yes,
will
ma'am.
be more than happy to work with. But there
Sure.
are n number of things which we need to consider. The most important is your inoculum. If your inoculum is not having right kind of microorganism, nothing will process. We
agree with you,
believe
ma'am.
that it will we believe that cow dung se aa jayega, but it doesn't happen like that.
Email mera de do. I am sharing my
Thank you,
email.
ma'am.
You can send me this thing. I'll get you, give her details. Okay.
Sure, ma'am. Sure. Thank you, ma'am.
I-
Thank you.
Yeah. Any other question? Yeah, Dr. Das. Anyone is there? Yeah. Any question, Mr. Das? I just wanted to say, you were saying about Samarth and all that. They are all talking of capacity building. They don't talk of skilling. That day also I told Mr. Nag, capacity building and skilling are entirely different activities. So they have promised to include it because Samarth is a very big mission. They're touching all
So,
the
ma'am,
states.
Ma'am,
Yeah.
my suggestion to Samarth program and Dr. Nag, maybe we can present together at
Yeah, we
some
can meet.
occasion,
Yeah, I wanted
is
to meet him.
that they have to look into this decentralized model which we are talking about, number
Yeah.
one, and which should integrate many other factors which are there in biomass aggregation and all
Yeah.
those kind of a thing.
Yeah.
Then only this effectively, more sustainably, they will able to achieve the long-term target under the
Yeah.
Samarth program. So maybe we can go and meet
Yeah,
them
we can go and meet them
together
together.
and yeah.
Yeah. We have Mr. Sarabjit also. So if he's there, Mr. Sarabjit, any comment? He's also there in the biogas. You know him for such a long time.
Yeah.
Mr.
Dr.
Sarabjit,
Sarabjit,
are you there? No. So if there are no more questions, I would like to thank Mr. Dhingra. And we had a very nice discussion, and this is endless, until unless we reach our goals, this discussion is, we can keep on
Yeah.
discussing. We've been discussing
I
for the
have
last.
one suggestion actually.
Yes, please.
I have one suggestion from
Yeah,
Tripura.
please, your name, please.
Dear Das, Joint Director from TREDA.
Okay. Yeah, please.
Biogas, as my experience, biogas have some potentiality in rural areas. We installed a good number of
You are in
biogas plants for
Tripura?
Tripura, yes, Tripura.
Tripura, yeah, Tripura, no? Yes, okay.
My suggestion is this biogas we can expand the more in more numbers if we add some economic some linkage. Suppose in manure and some cooperative mode, the collection of the manure, one cooperative farm will collect and make it as manure or vermicompost.
Yes.
And in marketing mode, such type of business model require for more acceptability of the biogas in our rural and some
I think
semi-urban areas.
this is already there, Mr. Meena. This vermicomposting and all these processes are already there in our biogas program.
Ma'am, for MDA assistance, a lot of work has been, under process. Shortly, we will have a consolidated scheme guideline and mechanism for the MDA assistance.
Yeah, I saw certain plants in Maharashtra where the women, they had picked up the manure and they
this
were
is my one
converting to
suggestion.
vermicomposting. Yeah. So any other questions?
This is ma'am.
Yeah.
This way. That's all, ma'am. Okay, thank you.
Daksha, before you thank, let me really thank Dhingra Saab.
You thank with all
I will always
full,
learn
this
some
thing.
new things whenever you speak. Always. वैसे तो मेरा बहुत ज़्यादा इसमें दखल नहीं है इस फील्ड में, पर it is always good to know what is really happening on the ground and rural areas, which we quite often miss. So thank you very much for Dhingra Saab for spending some time with us. Thank you so much.
Yeah.
Thank you so much.
You want to say something? No. So I think so. You have already thanked. I also thank you once again for taking out time and opportunity. We missed you out so many times, but this time you made it.
Yeah, thank you so much. Thank you so much.
Thank you very much. So
Pleasure.
We were
It's
thinking
pleasure.
at least, but there are so many. We will certainly take it up with Samarth.
Sure.
They need to be
We'll
guided further. Yeah.
Yeah, absolutely. Yeah. Thank you so
Thank
much. Thank you,
Okay,
everybody.
bye-bye, bye-bye. All the
Thank you.
best.
Bye
And,
bye.
PB Singh ji,
Thank you.
make
Thank
a
you, sir.
formal, formal thanks.
First, I would like to thank Mr. Dhingra for accepting our invitation for this presentation. As you speaker, today SCGJ completed 90 webinars. Dhingra साहब आप witness हैं इसके today SCGJ 90 complete कर लिया है. Thank you for the excellent presentation. It's a very informative and knowledgeable. Hope all the participants get benefited once again. And and you handle the question answer session very well. Thank you very much, sir. Now I would like to thank all the participants for their valuable presence and support. Your presence is provide motivation to us. Thank you very much, all of you. I would like to thank Dr. Dhamija ma'am for the support and valuable guidance. And also thanks to Mr. Rohit for his IT related support for this webinar. Once again, thank you all.
Thanks a lot. Yeah.
Thank you. Thank you so much.
Have a good
Thank
day.
you so much.
Yeah,
Bye.
please.
Bye. Bye.